this screencast, I will cover the answers to the learning activity on bonding. The learning objective of this activity was to differentiate between ionic, nonpolar covalent, polar covalent, and hydrogen bonds. First, you were asked to inspect the equation. What do we have here? On the left of the arrow, our reactants, we have two atoms, sodium atom and a chlorine atom. And the sodium atom is donating an electron to the chlorine atom. That yields ions on the right side of the arrow. So we have a sodium ion and a chloride ion. They are charged because the sodium donated an electron. Therefore, it has one fewer electrons than it has protons, and the chlorine atom received that electron, so now it has one more electron than it has protons, so it is also charged. So the very first question was, what are A and B, and what are their charges? And what I wanted you to recognize was that these are atoms, and it says it in the actual image. It says sodium atom, chlorine atom. What are their charges? 0. Net electric charge. 0. Net electric charge. 0. Atoms are electrically neutral because they have equal numbers of protons and electrons. Now let's move to the right side of the equation. The question number 2 was, what is C's charge and why? Because sodium had given up or donated an electron, it now has 10 electrons but 11 protons. It has one more proton than it has electrons. Protons are positively charged, electrons are negatively charged. Because it has more protons than electrons, it has a charge of +1. And it is no longer sodium atom, it is sodium ion. So its new name, it is an ion. Specifically, it is a cation because it is a positively charged ion. Number 4, what is D's charge and why? D is chloride ion. It received an electron from sodium, so now it has 18 electrons, only 17 protons, so it has a charge of -1. Question number 5 was, what's D's new name? It is an anion specifically, so it's an ion. I'll put in here, it is a negatively charged ion, which is also called an anion. And it is no longer chlorine atom, it is a chloride ion. By convention, we change the ending of the name of the atom, adding IDE when it is a negatively charged ion. So it was chlorine atom, it is now chloride ion. What type of bond has been formed between C and D? The answer is an ionic bond. Ionic bonds are formed when one atom donates an electron to another atom. And now we have two ions of opposite charge, and they're attracted to one another. And that attraction is the ionic bond. Number 7, what are C and D together called? Well, we had atoms that became ions. Those ions are attracted to one another, and so now we have an ionic compound. We had atoms, now we have a compound. These two ions together are referred to as a compound. Specifically, they are a salt because they are an ionic compound. Any ionic compound is also a salt. Let's move on to our next reaction. Here we have two oxygen atoms, and they're going to share two pairs of electrons to form an oxygen molecule. So now let's answer the question. What are A and B, and what are their charges? Well, I don't have the charges below them in this example, but if atoms were neutral in the previous example, there's no reason to believe they wouldn't be neutral in any other example. So, atoms are what we have here, A and B, and they're uncharged. They're neutral. What is C's charge and why? Well, we didn't lose any electrons. We didn't gain any electrons. We simply have two atoms that were neutral, and they are sharing two pairs of electrons, and they're sharing them equally. So, this oxygen molecule has no charge. It's the atoms which make up that oxygen molecule were neutral, and the oxygen molecule itself is neutral. So there's no charge. What specific type of bond is formed between A and B to form C? When atoms share electrons, it's a covalent bond. When they share them equally, as what is occurring here, it's a nonpolar covalent bond. Okay, and here, since they're sharing two, it's also a double covalent bond. So it's a double nonpolar covalent bond. What's most important is that you recognize it's a nonpolar covalent bond. And number 4 was, what do we call C? C is a molecule. It's what's called molecular oxygen. Okay, it is a molecule. Why is it not a compound? Well, a compound is formed by two different atoms. Here we have atoms of the same element. So it is a molecule, but it is not a compound like sodium chloride was. In this third reaction, we have an atom of oxygen that is going to form bonds or react with two atoms of hydrogen to form water, which is H2O. Question 1, what are A and B, and what are their charges? Again, these are atoms, so they are uncharged. Question 2, what is C's charge at the oxygen end and why? C is slightly negative at the oxygen end because while oxygen and the two hydrogen atoms share electrons, they share them unequally. The electrons spend more time around the oxygen than they do around the hydrogens. So the oxygen end of this molecule is slightly negative. The oxygen hogs the electrons. Question 3, what is C's charge at the hydrogen ends? I'm going to add an S there. And why? Well, if those electrons spend most of their time around the oxygen such that the oxygen end is slightly negative, you would expect the hydrogen end to be slightly positive, and it is. The delta means slight, by the way. So, the hydrogen ends are slightly positive because those electrons that they're sharing spend most of their time on the oxygen end. What type of bond is this called? Well, a covalent bond is a bond formed by sharing. If they're shared equally, it is a nonpolar covalent bond. If they are shared unequally, as is the case here, it is a polar covalent bond. I then asked you to come up with 3 names for this product here, C. And I said I can think of 3 names. One is a molecule, come up with two others. It is a molecule, but it is also a compound. Remember, a molecule is formed by two atoms, any two atoms. So it is a molecule. A molecule is a compound if more than one of the atoms is a different element. And of course, we have carbon and we have hydrogens. So it is also a compound. Someone mentioned during our discussion that it was a product, and of course it is. Not exactly what I was looking for, but yes, it is a product. The third name I could think of to describe this molecule is dipole, because there is two ends with different charges. The hydrogen end of the water molecule has a slight positive charge, and the negative end of the molecule has the oxygen end of the molecule has a slight negative charge, and that is called a dipole. Now, what is the significance of a dipole? So in other words, why do we care that the hydrogen end is slightly positive and the negative end is the oxygen end is slightly negative? What's the significance of that? Well, the significance is a dipole, such as oxygen, is attracted to other charged particles because one end is slightly positive. That end is attracted to other to negatively charged particles. The oxygen end is slightly negative, so it is attracted to positively charged particles. And this includes other water molecules. So the hydrogen end of one water molecule is attracted to the negative end of another water molecule. And a bond is formed by that attraction. And so Q1 was, what type of bond is formed between these two water molecules and why does it form? The answer is the bond that is formed between the hydrogen end of one water molecule and the oxygen end of another water molecule is called a hydrogen bond. It forms because the hydrogen end of one water molecule is positively charged and the oxygen end of another water molecule is negatively charged. Question 2 is, how is this bond different from the previous ones? So how is a hydrogen bond different from ionic and covalent bonds? Note that ionic and covalent bonds were bonds formed between atoms. This bond is formed between molecules, between one water molecule and another water molecule. These are what are called intramolecular bonds between molecules. These are extremely important bonds, as you will see shortly as you learn about the properties of water. And later on, when you learn about the structures of proteins, hydrogen bonds play a critical role in both. Question 3 was, is this bond weak or is it strong? Well, note that this bond results from an attraction between the slightly positive end of one water molecule and the slightly negative end of another water molecule. So it's going to be relatively weak. So even though it's extremely important, it is a weak bond. It can be easily broken by an increase in temperature or a change in pH. And as you will learn later, that is why biological systems, living organisms, are very sensitive to changes in temperature and pH.